grade 9 program. The topic for today is inequalities. It is the second video on inequalities. You will recall that in the first video, you had learned how to represent linear inequalities on a number line. In today's session, you will learn how to solve linear inequalities. So let us start. Solving inequalities. What does it mean to solve an inequality? It means to find a set or a range of values which satisfies the inequality. Let us take the first example. Given that x is an integer and x lies between -3 and 2, write down all the possible values of x. Let us have a look at the solution. So x lies between -3 and 2. What does it mean? It means that x can take values between -3 and 2, but x cannot be equal to -3 and 2. So you will recall that in the first video, we had learned how to represent such inequalities on a number line. So here I will have two empty circles at -3 and 2 to indicate that x cannot be equal to -3 and x cannot be equal to 2. But x can take any values in between. Now remember that x is an integer. So x cannot be equal to -3, x cannot be equal to 2, but x can be equal to -2, -1, 0, and 1. So x can take the different possible values, that is -2, -1, 0, and 1. We move on to the second example. Solve the following inequalities. So we have 4 parts in this example. The first part is x plus 2 greater than 6. Let us look at the solution. So I'm going to proceed just as when we have to solve an equation. So the additive inverse of 2 is -2. So I'm going to add -2 on both sides. You will recall that 2 plus -2 will give me 0. 6 plus -2 is equal to 6 minus 2, which is 4. So the answer is x greater than 4. Part B. X minus 3 less than -8. So the additive inverse of -3 is +3. So I add 3 on both sides. And I get x less than -5. Part C. X minus 5 less than or equal to 3. So the additive inverse of -5 is 5. I add 5 on both sides of the inequality. And I get x less than or equal to 8. Part D. X plus 6 greater than or equal to -2. So the additive inverse of +6 is -6. I add -6 on both sides to obtain x greater than or equal to -8. Example 3. Solve the following inequalities. So I have 4 parts in this example. The solution to part A, 2x greater than or equal to 6. So the multiplicative inverse of 2 is half. So I multiply by half on both sides. And I get x greater than or equal to 3. Part B, y over 3 greater than negative 1. The multiplicative inverse of 1/3 is 3. So I multiply by 3 on both sides. And I get y greater than negative 3. See? Here we have two operations. So first I need to eliminate the minus 3. So the additive inverse of minus 3 is plus 3. I add 3 on both sides. And I get 5x less than 15. Now to eliminate 5, I need to multiply by the multiplicative inverse of 5, which is 1/5. So I multiply by 1/5 on both sides. And I get x less than 3. Part D, 2s over 3 plus 4 less than or equal to negative 10. So first I need to eliminate 4. To cancel 4, I add the additive inverse of 4 on both sides. That is, I add negative 4 on both sides. And I get 2s over 3 less than or equal to negative 14. I now multiply by the multiplicative inverse of 2/3. That is, I multiply by 3 over 2 on both sides. Finally, I'm going to get s less than or equal to negative 21. That is 3 times negative 7. Now we're going to consider some special cases. Consider 3, which is less than 5. If I multiply or divide by negative 1 on both sides, we are going to have negative 3 less than negative 5. But we all know that negative 3 is greater than negative 5. Okay? Negative 3 is greater than negative 5. Hence, given that 3 is less than 5, then negative 3 is greater than negative 5. We again consider 3 less than 5. Now, if we take the reciprocal of both 3 and 5, we have 1/3 less than 1/5. 1/5 is equal to 0.2. 1/3 is equal to 0.3333, and so on. So 1/5 is in fact less than 1/3. Hence, given that 3 is less than 5, then 1/5 is less than 1/3. So what have we noticed from these two different cases? We have seen that the inequality sign is reversed when we multiply or we divide by a negative number, as well as when we take the reciprocals. So what does it mean the inequality sign is reversed? It means that we change the inequality sign. If it is less than, we change it to greater than. If it is greater than or equal to, we change it to less than or equal to. We consider the fourth example. Solve the following inequalities. The solution to part A. Negative 3x less than 18. So here I will have to multiply by the multiplicative inverse of negative 3, which is negative 1/3 on both sides. Remember, I'm multiplying by a negative number. So I will have to reverse the inequality sign at the same time. So you can see here, I had less than. When I'm multiplying by negative 1/3 on both sides, the inequality sign has changed. It has reversed. So I'm going to have x greater than negative 6. So here I have negative times negative times positive, which is negative. Part B, negative v over 5 greater than 6. So the multiplicative inverse of minus 1/5 is minus 5. I multiply by minus 5 on both sides, and I have to reverse the inequality sign at the same time. So I get v less than negative 30. Part C, 2 minus 4x less than negative 6. So first I need to eliminate 2 on the left-hand side. How do I proceed? I add the additive inverse of 2 on both sides of the inequality. So I get minus 4x less than minus 8. Now I multiply by the multiplicative inverse of negative 4 on both sides. So I multiply by minus 1 over 4 on both sides, and don't forget to reverse the inequality sign. I get x greater than 2. Part D, 2 minus 6y over 7 greater than or equal to negative 4. So I first multiply by 7 on both sides. And I get 2 minus 6y greater than or equal to negative 28. Now I need to add negative 2 on both sides. And I get minus 6y greater than or equal to negative 30. We now multiply by negative 1 over 6 on both sides, and we reverse the inequality sign. We get finally y less than or equal to 5. Example 5. Given that 2x plus 5 less than or equal to 22, state the largest possible value of x if part A, x is an integer, part B, x is an odd number, and part C, x is a square number. So first, we are going to solve this inequality. So you can see that 2x plus 5 less or equal to 22. We proceed as in the previous examples. So I add minus 5 on both sides. I get 2x less than or equal to 17. I multiply by half on both sides to finally obtain x less than or equal to 8.5. So if you look at this number line, x less than or equal to 8.5. This means that x can take all these values to the left of 8.5, including 8.5. However, for part A, we have been asked to find the possible values of x if x is an integer. So x can take as integer values 8, 7, 6, 5, and so on. But the largest possible value of x will be 8. Part B, x is an odd number. So odd numbers less than 8 would be 7, 5, 3, and so on. But the largest possible value would be 7. Now, for part C, x is a square number. So square numbers less than 8 would be 4 and 1. But the largest possible value would be 4. You have some exercises which you can practice. So question 1, given that x is an integer and that x lies between -3 and 3, write down all the possible values of x. You have a similar question for number 2, same for number 3. Number 4, you have to solve the following inequalities. Number 5, also you need to solve the following inequalities. Number 6, also, here you have to be careful because we have a negative. So these are questions just like the last example which we have seen. You also have some links for additional practice, for more reference on how to solve linear inequalities. So friend, in today's session, we have learned how to solve linear inequalities. This was the second part of the chapter Inequalities. We have also worked a few examples for you. So we have a third video on inequalities. And until we meet again, it's goodbye from me.